We may be asked to graph polar graphs by hand, where we do what our calculator does to generate the curve. That's we pick theta and calculate r. Now, we're picking theta and calculating r. We're picking the directed angle and calculating the directed distance. However, when we report and graph, we do r theta. So we reverse it and we do directed distance, comma, directed angle. If I'm asked to graph r equals 4 sine theta, I can start by just putting in 0 for theta. Sine of 0, if I remember my unit circle, is itself 0 times 4 is 0. So if I'm graphing this, I get this point here. Notice anything with an r of 0 is going to be right there at the pole, no matter what the angle is. Pi over 6. Well, if I'm choosing, pi over 6 are very friendly with sines, because if I go to my unit circle, I know that sine of pi over 6, I'm using this particular triangle. Anything with pi over 6 is going to have a 1/2 in front of it, and a root 3 over 2 is going to be adjacent. So anything with pi over 6 is going to be very friendly to do with sine, because it's easy. We can do it right in our heads. Sine of pi over 6 is 1/2 times 4 is 2. So that at an angle of pi over 6, which is out this way, I'm out 2. So I didn't draw my rings in, but here's my first ring and there's my second ring. Pi over 4. Well, remember, with your unit circle, if you have pi over 4, we're talking about root 2 over 2, root 2 over 2, and 1. So sine is opposite over hypotenuse. So this is root 2 over 2 times 4 is 2 root 2. I know root 2 is about 1.4 times 2 is about 2.8. So at an angle of pi over 4, I'm at 2.8. Pi over 3. Well, if this is pi over 3 and I look through this angle, the sine is root 3 over 2 times 4 is 2 root 3, which is about 3.5. So at an angle of pi over 3, I'm at 3.5. At pi over 2, sine pi over 2, on the unit circle that's right at the top, 0, 1. So 1 for sine of 90 degrees, or pi over 2 times 4 is 4. So I get this point right here. 2 pi over 3, well, sine, remember, we have to think about all students take calculus. So ASTC. So in the second quadrant, sine is positive. Sine 2 pi over 3 will be root 3 over 2 times 4 is 2 root 3. So that will give us another 3.5 thereabouts. And so I'm going at an angle of 2 pi over 3, and my directed distance is 3.5. 3 pi over 4, well, sine is positive. It's going to be root 2 over 2 times 4 is 2 root 2, which is about 2.8. So right here, I'm at 2.8. And finally, 5 pi over 6. Well, sine 5 pi over 6 is 1/2 times 4 is 2. So at 5 pi over 6, I'm 2. And sine of pi, when I put a pi in for a pi for theta, sine of pi is 0 times 4 is 0. And so I'm again back here. And we get this nice circle. If I continue to expand beyond pi, I'd just be repeating the circle over and over and over again. One thing I forgot to mention here is that when we graphed our r equals 4 sine theta, notice we had a sine here, and we have theta equals pi over 2 symmetry. That's no coincidence. Anytime, well, almost anytime, we see sine, we're going to have at least this theta equals pi over 2 symmetry, meaning this half will be mirrored over here. Here we're asked to graph r equals 3 plus 2 cosine theta by hand. So again, I just pick theta and I'm going to calculate r. I've got to know my unit circle well. When I put in a 0 for the angle, cosine of 0, I got to know is over here. That's going to be 1 times 2 plus 3 is 5. Pi over 6, cosine of pi over 6 is root 3 over 2 times 2 is root 3 plus 3 is about 4.7. pi over 4, cosine pi over 4 in quadrant 1 is root 2 over 2 times 2 is root 2, which is about 1.4 plus 3 is about 4.4. Pi over 3, cosine pi over 3. Well, I love cosines in pi over 3 because if I have pi over 3, I know the cosine of that is 1/2 because opposite will be root 3 over 2. So 1/2 times 2 is 1 plus 3 is 4. Pi over 2, cosine pi over 2 is 0 plus 3 is 3. 2 pi over 3, well, that's going to be a reference angle of pi over 3, but in, remember, ASTC, in this quadrant will be negative, and that is going to be negative 1/2 times 2 is negative 1 plus 3 is 2. 3 pi over 4, well, that's going to be, cosine of 3 pi over 4 is negative root 2 over 2, times 2 is negative root 2, which is about negative 1.4. So 3 minus 1.4 is about 1.6. 5 pi over 6, cosine of 5 pi over 6 is going to be negative root 3 over 2 times 2 is 3 minus root 3, which is about 1.3. And if I put a pi in here, cosine of pi is negative 1 times 2 is negative 2 plus 3 is 1. So when I graph this, I'm graphing, remember, r theta, so I'm turning this around, directed distance at this angle. So if I go out 5 and at an angle of 0, there will be my point. At pi over 6, my angle, my directed distance is 4.7. At a directed distance of 4.4, I'm at pi over 4. Directed distance of 4 at pi over 3 puts me about right there. And I'm at pi over 2, my directed distance is 3. So that's 5 and that's 3. Now when I come to this back side here, 2 pi over 3, I'm only at 2. 3 pi over 4, I'm at 1.6. 5 pi over 6, I'm at 1.3. And finally, when my angle opens to pi, I'm at 1. Now notice, I could keep on going and pick thetas, or the angle, from pi to 2 pi, and just keep on going and drawing the rest of it. But I'm going to use my head. I'm going to work smarter, not harder. I recognize this shape here looks like that. And because I see cosine, I know I have symmetry across the polar axis. So whatever happens here will be mirrored here. And those of you who have done studying ahead, you'll recognize two terms means it's limacon. If A is slightly bigger than B, it will be a dimpled limacon. 3 plus 2 is 5, so that's 5, 0. 3 minus 2, absolute value, is 1, so we'll be 1 this way at an angle of pi. And we're going to be up 3 and down 3, because that's my A, to give me this point 3 comma pi over 2. And here I'd have 3 comma 3 pi over 2. But that's for later, when we understand what these special polar graphs look like that. So if we're going to graph one more of these by hand, we're given r equals 2 cosine 3 theta. Notice that we are going to have to replace theta, then immediately multiply by 3, because we're following PEMDAS, parentheses first, then exponents. So if I replace this with, say, again, my usual culprits, 0, pi over 6, pi over 3, pi over 2, I'm sorry, let me put a pi over 4 in there, just for the rock of it. Pi over 4, pi over 6, pi over 2. Let's start with those. 0. I put a 0 in there and I say 0 times 3 is 0. Cosine of 0 is 1 times 2 is 2. Then pi over 6. Pi over 6 times 3 is pi over 2. Cosine pi over 2 is 0 times 2 is 0. Pi over 4. Pi over 4 times 3 is 3 pi over 4 times cosine, cosine of 3 pi over 4 is negative root 2 over 2 times 2 is negative root 2. So that's going to be about negative 1.4. Pi over 6. Pi over, I'm sorry, I meant to put pi over 3. Cosine pi over 3, this is really cosine 3 pi over 3, which is cosine of pi. Negative 1 times 2 is negative 2. And pi over 2, cosine of 3 pi over 2 is 0. I'm putting a pi over 2 in there. I get cosine 3 pi over 2 is 0 times 2 is 0. So let's see what this looks like so far. If this is my polar axis and this is my theta equals pi over 2 axis, I'm at 2, 0. So maybe that's there. And then 0 pi over 6 is right there. Pi over negative 1.4 pi over 4. Well, 1.4 pi over 4 is there, so I'll reflect it down here. Pi over 3 gives me negative 2, so this is 2 pi over 3 is there. So negative 2 pi over 3 is going to be, this one would be there, and this one would be there. And then we go back to 0. Now, I know this is nuts, but I also know that this looks like this. If I picked more points, I would see this looks like this. And I'm sure you could pick points as we did in class, like if I pick pi over 12, pi over 12 times 3 is pi over 4. Cosine pi over 4 is root 2 over 2 times 2 is 1.4. So pi over 12, 1.4 does give me a point there. So you can see I was correct in that regard. I get this. Now notice it's cosine. So I know that whatever happens above the polar axis is going to be reflected below the polar axis. So I'm drawing this dotted. It's a ghost. This will be reflected directly up. So it's going to look like this. And of course, if you're looking back at this now, you'll say, of course, it's a cosine. It's got one term. It's a rose with 3 petals. Each is 2 long. And because there's 3 petals, we're saying 360 degrees divided by 3 is 120 degrees between the petals. And you can see if I bisected the petals, this angle is 120 degrees or 2 pi over 3. If I did another 120 degrees or 2 pi over 3, I'd get the next petal. Sorry, that's 2 pi over 3. And then I'd go back another 120 degrees or 2 pi over 3 and I'd get my final petal. I'm no magician. If I had just kept on picking points, I would have gotten all of these points. If I had chosen pi over 12, I didn't pick my points very wisely. I didn't pick my angles very wisely. If I had picked pi over 12, pi over 15, pi over 9, etc., I would have gotten lots and lots of points here. And then I could have still stopped when I got to pi over 2 because I have enough to do the mimic right here, or the mirror image over this polar axis. How do I know? Because it says cosine, and anything with cosine is going to have a reflection over that polar axis.